Yeah, so my name, thank you, Emily. So my name is Nelson Vaz. I'm the warning coordination meteorologist with the National Weather Service office out of New York, New York. So Upton, New York, we're located out on Long Island, but we serve Lower Hudson Valley, Northeast New Jersey, New York City, Long Island, and Southern Connecticut. And so I've been there close to 20 years, and forecaster for 16, 17 years of those, and the last 4 years warning coordination meteorologist. So part of my job is interfacing with our partners and making sure our products and services and also the public, and public safety partners, our academic, governmental partners, media partners, making sure our products and services are meeting the needs of needs of our partners for public safety decisions, but also are they allowing the public to properly prepare and understand hazardous, not prepare for hazardous weather, but understand the watches, warnings, advisories we're putting out and the information we're putting out. So, so opposite of the last presentation, I'm going to be talking about floods, and I'm going to go a little bit about the flood history locally and our products and services that we provide. So, try to hopefully I can get through all my slides here, but we'll give it our best shot here. So to start off, in terms of, why is even, freshwater flooding important? This is just looking at this chart. You're basically looking at over the last about 14, 15 years here, the fatalities that we've had in our local tri-state area. And, by number one by far is heat. This is the number here is just the fatalities that are directly associated with heat, but indirect fatalities, just in New York City alone, you're talking about over 300 a year. So this is severe, I think significantly underplayed. But after that, storm surge, rip currents, floods, tropical winds are all kind of associated or strongly associated with tropical systems. And of course, the flood, which kind of more topical for this presentation and this group, unfortunately, so a lot of those fatalities that we see are from Ida. And I'll kind of quickly go over that, and also and Irene as well. That was where the predominant amount of these fatalities were from, is these tropical systems, which we don't, or tropical systems or a system with tropical moisture, but which are not overly frequent in our area, but unfortunately are some of the highest impact events for our area in terms of fatalities and catastrophic damage. And just quickly, just in terms of the meteorological, what are some of the factors that go into flooding in the tri-state area? And particularly what we kind of face here more in the kind of the downstate area and more of our urban flashy kind of flood basins is really the flash flooding, is quite a bit of rainfall in a short period of time, overwhelming storm drainages in the urban areas, and then overwhelming the small kind of flashy small rivers, streams, and creeks, causing rapid flooding. So importantly, precipitation rate. And all kind of associated, the precipitation rate, how heavy the rainfall, really associated with the, basically the amount of lift you have in the atmosphere, the amount of moisture, and even instability, which is kind of just kind of energy that enhances the lift. And that helps to kind of develop deeper thunderstorms or deeper, what we call convection. So, updraft or bringing more moisture into the air and then coming down as heavier rainfall. So precipitation rate is, of course, key. The coverage of that, is it just in an isolated spot, like an isolated thunderstorm, or are we looking something maybe more tropical in nature, or, a stalled boundary where we're looking at precipitation or heavy rainfall rates over a whole river basin, a whole urban area, so overwhelming a whole storm drainage, or overwhelming the whole tributary, and then kind of flowing down to secondary and main stem kind of rivers, and then the duration. So kind of the ingredients we're looking for ahead of a system, are they coming together to start kind of our watch warning process, our watch process, and then during an event, really monitoring how those are all coming together in terms of our warning process. And then, of course, there's other compounding factors in terms of just, is it urban versus riverine, as we said? Are we looking at high tidal, so especially along the coast or tidally affected rivers? How is that affecting it? Snow melt, previous predecessor rainfall. Are we already have high soil moisture, high stream flows? All those different things come into effect. We're all those things we're looking at. And then, just in terms of, and another thing is, I'm talking about in terms of where our most, kind of really our most impactful rainfall events. Those are from our tropical systems, really, and they don't make up 70% of our flash flood cases. Really looking over the last decade and a half have been from thunderstorms, and they're generally more isolated or scattered. But the more widespread and really more devastating, usually flooding events, are usually from tropical systems. And so in the beginning of this presentation, just kind of concentrate a little more on that tropical, heavy rain hazard. And really, the big thing, the reason for these tropical systems being, such a big, heavy rain producers are because just innately, because of their makeup in terms of starting with a kind of a warm core, and being fueled by warm water and instability over those warm waters. They hold a lot of moisture, and so that the ability to hold all that moisture is really kind of the part of the key. But then how quickly are they moving? And looking at here, some of the most prolific rainfall producers in our area have been really slow moving. Generally less than 30 miles per hour. So we can look at Floyd in 99, Irene, 20, 25 miles per hour, Diane, and which had been preceded by Connie, and then also in 1955, and then Agnes in 1972. All slow movers with a lot of moisture, and then just having to, releasing all that moisture over our area. Ida was a relatively slow mover, and we'll get into the Ida actually right here. The thing that made Ida unique is it wasn't even a tropical system anymore, what we consider post-tropical. It lost its tropical characteristics, kind of warm core, strongest winds down near the surface and along the, around the eye. The circulation had become kind of lost its tropical characteristics and really became a remnant low, post-tropical low. But because of the atmospheric, the synoptic conditions, more typical of like wintertime, a strong jet stream that really helped to enhance this kind of low pressure system. And then also being early September, we had instability or kind of energy that this system could work with that helped for deeper convection. So, more prolific rainfall rates, all this coming together, increased lift from the kind of the high latitude energies and the instability allowing for kind of deeper convection. So really intense rainfall rates. And that was really the key with this. We saw 5 to 9 inches of rain, but the real key was where it fell across. And first predecessor conditions had been a wet summer. Fell across northeast New Jersey, lower Hudson Valley, New York City Metro, southern Connecticut, all in a short duration, and where rainfall rates 3, maybe as much as 4 inches per hour, over areas that really can't handle more than maybe 1.5 inches per hour before the storm drainage get overwhelmed, and even in cases less than that before you start flooding in some of these areas. So we knew, unfortunately, a lot of fatalities, 27 in our tri-state area, but widespread catastrophic urban and small stream flash flooding. Just kind of a map showing what the rainfall trace looked like. Those purples, anywhere 6 to 9, some 10 inches of rain in spots, and a lot of that falling in very short period of time. This is from the New York State Mesonet, just showing we're looking at in 5 minutes. Some 5-minute rainfall in excess of 1/2 inch in an hour in New York City. 15-minute rainfall, 1.5 inches. And again, that's the 1 hour rainfall rate, 1.5 inches around there that the storm drainage systems can handle. So we were seeing that in 15 minutes, and 1 hour rainfall in some cases 3-4 inches per hour. And, and if you kind of take a look at it in terms of, this is from the Office of Water Prediction, what does that translate into, in terms of a recurrence interval or an annual exceedance? And this is looking at past, past rainfall kind of data, event data, looking at magnitude and duration, kind of creating magnitude and duration curves. This was kind of classified as a 1 in 1,000 year event, or 0.1% chance of really of occurrence. And so, something that you think is not going to happen very frequently, but I'll show later that unfortunately we've actually seen 3 of these events. Not similar, not exactly like Ida, but 3 of these 500 to 1,000 year events in the last just the last decade. And just some of the pictures, I think we're all pretty familiar with occurred with Ida. But not only talking about Ida, so that was you had extreme rainfall rates in a short period of time. But other events that we've had, tropical events, just a tremendous amount of rainfall with with an event over a 24-hour period. So how much can we expect with a tropical system? Really 15 to 20 inches is what we kind of look back in history. Agnes in Pennsylvania through 19 inches. We had Diane, which anywhere 15 to 20 inches across Massachusetts and Connecticut, and Irene anywhere as high as 18 inches, with Irene. And so seeing that amount in 24 hours, again, that's approaching 200 to 500 year recurrence intervals. Just quickly, Tropical Storm Floyd, 1999. Just took a track right along the coast, and traditionally with these tropical systems, the heaviest rain, as it's making that kind of transition to a little more extratropical, is going to be on the westward side of the storm, especially when you kind of get into some orographics, away from the coast, where it can help to enhance things. But as much as 10, 12 inches of rainfall, and numerous rivers kind of reaching historical or 50 to 100 year return intervals. Unfortunately, 5 fatalities with Floyd across just the local tri-state area. New Jersey, especially hard hit, northeastern New Jersey, but as well as Connecticut and New York, all seeing quite a bit of riverine, stream flooding, and also some of that affecting roadways and homes along these areas. Tropical Storm Irene, which was 2011, very similar type of rain swath with that. Another tropical system tracking right along the coast, and again the west side areas seeing as much 5-10 inches of rainfall. Again, several kind of record flood stages reached with this storm, and again 4 fatalities due to drowning. Unfortunately, the other thing with Irene was you had the coastal flooding issues, which could, especially in northeastern New Jersey, combined. The high elevated water levels in some of the estuaries with that rainfall kind of exacerbated things. And just some of the pictures you can see along the Rahway River, Passaic River, even into Staten Island, Danbury, so the Still River, quite impactful rainfall. And then kind of working up into the upstate of New York as well. And the other thing with this, right after Irene, then we had Lee just within a week of that, and so the combination of this, I think a tremendous amount of flooding, especially as you went further into the upstate, that kind of continued. With areas 15, 20 inches of rain and then 20 plus. So right in that kind of ballpark of where, what is something that we can expect or potential, especially when you have like these kind of coincident tropical systems. And then, that didn't just happen with in 2011 with Irene and Lee. We can go back to 1955, Connie and Diane. Another situation where within a week of each other, you had 2 tropical systems affect the other area. First with Connie, August 11th to 15th, and that one took more of a kind of an inland track, but still produced quite a bit of heavy rainfall, up into the area, anywhere 5 to 10 inches of rain. I think significantly, especially across the New York City, New Jersey, tri-state area and down to the mid-Atlantic. And then you had Diane, which was just kind of several days later, that produced some really prolific rainfall into southern New England and southeastern New York. So with that, combined with these, you had some areas that saw anywhere 1 to 2 feet, and especially into southern Connecticut, Massachusetts area, some 2 feet of rain in just a week, which you're exceeding your 500 1 in 500 year type of event. Over 100 fatalities, thousands injured, hundreds of homes, roads, and dams damaged or destroyed, especially in Pennsylvania and Connecticut with both these systems. And just some pictures in terms of some of the hardest hit areas in Northwest Connecticut here, the Mad River, Litchfield County, and the Naugatuck in Torrington, Connecticut. Tremendous damage around there. And just one finally, the Tropical Storm Agnes, 1972. This was one that really hit Pennsylvania and into south central New York quite hard. Areas again, 10 to 15 inches of rain. Another, as I mentioned with these other ones, slow movers. These moving less than 20 miles per hour. So slow moving, not that, and at this time, fairly. Not the biggest punch was not from storm surge or the winds, but just the heavy rain moisture that was still with these. And quite a bit of flooding with this along the Susquehanna, Lackawanna, and upper Allegheny rivers. A lot of damage to roads, rails, farmland, and 50 fatalities alone just in Pennsylvania from Agnes. And so some of the pictures as we're going into south central New York of some of the flooding along the Chemung River there. So, and so you can see, kind of give you a sense in terms of what we can see, in tropical, and those are all been in the last basically like 70 years, several events that we've seen. But you don't even need a tropical system. Actually, as I was talking, Ida was a 1 in, a 0.1% chance in any year, 1 in 1,000 year event. But two others we've seen, and that weren't tropical systems, were September 25th, 2018. We had it was basically just a stalled boundary, like a front that stalled over the Connecticut area. You can see in the upper right, and those yellows there are how much rain we saw in 6 hours. Basically 6 to 8 inches of rain, and some of the rainfall rates getting in excess of 2 inches per hour. And the result, this again was putting you at a 500 to a 1,000 year event. And some of the pictures, we saw a lot of major roadway flooding, and enough flooding or swollen rivers and creeks to cause damage to some bridges, to roadways, and a lot of water rescues with this. So, this is another 1 in 500 to 1,000 year event, all that we've seen, 2018, 2021 with Ida. And then you go back to 2014, this was just yet another one. This was over Long Island, another stalled boundary, tropical moisture, and just enough instability where you had the right synoptics basically to have training really heavy downpours right along that boundary for a few hours. We were looking actually at rainfall rates of up to 4 or 5 inches per hour across Long Island, leaving about a foot of rainfall in just really a 2-3 hour period. Again, a 0.1% chance of occurring. And the one fortunate thing about this was across Long Island, and not maybe northeastern New Jersey, lower Hudson Valley, southwestern Connecticut, or New York City, where near Long Island being more of a sandbar, being able to handle a lot of this. You can see some of the pictures from the major interstates, but it just brings to mind that we've seen it just in 10 years, we've seen 3 of these 1 in 1,000 year events. And I think part of what the Office of Water, in the Office of Hydrological Services, the water prediction is looking at is incorporating how how kind of a warming planet is affecting things. And this is just study from the interpanel IPCC report, NOAA, and kind of put together, or I got from NOAA climate.gov. But in terms of the changes in extreme precipitation, these 1% rainfall events, these extreme rainfall events, basically last 60 years or so, we've seen a 55% increase in that, those 1%, those extreme rainfall events. And especially in the Northeast, you can see here the most affected. And then you look into the future, whether you're looking at low or high emission scenarios, the increases continue for the Northeast. So, these, what we kind of deem or have them classified as the 1 in 1,000 year events, they of course will change, some of these, these rating curves, but I think the introduction of the climate scenarios will also introduce that, and that's what the Office of Water Prediction is working on, some of those NOAA atlases for the future. And I think I have a little more time. I think what I'm going to do here is just go through some of the products real quickly, so we can see what the threat is here, and that potentially could be even increasing into the future. But to handle that, this is what we do as the Weather Service, to provide products and services to help our partners to plan and prepare, and to help hopefully mitigate impacts. And first line of defense is maybe the Climate Prediction Center. And I think in line with the previous presentation showing the drought, the drought information system, Climate Prediction Center, their expertise is in the longer range, seasonal, weekly forecasting, and drought forecasting as well. Using climate prediction models, which are in these longer range models, but also looking at climate, large scale climate patterns, teleconnections, the mention of ENSO, El Nino, La Nina, but also other North Atlantic, Arctic, Pacific and Atlantic kind of patterns, to really predict, in the longer term, what are we looking at in terms of precipitation outlook. So a useful product, especially I think in terms of looking at larger scale river concerns and drought concerns. So as we get into more of the 1 to 7 day period, this is really where we, as the Weather Forecast Office, really kind of that's really our expertise and our focus. We work with our national centers, the National Weather Prediction Center. Their responsibility is on the whole scale nationally to produce precipitation forecasts, excessive rainfall outlooks, mesoscale precipitation discussions. And this is an example on the left and the bottom here of the excessive rainfall outlooks that you might be familiar with. Basically, what are the chances that rainfall is going to be heavy enough in a part of the country to cause flash flooding? So looking at local flash flood guidance, looking at annual return intervals, looking at, of course, at rainfall rate prediction, taking into account, the basics, the moisture lift instability, looking at high resolution modeling, and topography and soil concerns, so all that. And it's something we collaborate with us as a local forecast office, having the local expertise, and come up with a collaborative forecast in terms of what the outlook is going to be. And really, sometimes, marginal and slight risks, isolated scattered flash flooding potential, maybe locally kind of more significant. That's kind of typical during our summer season and warm season. But really, where we want to make sure we can kind of tease out and provide a heads up is these moderate and high end events. And that's really where a lot of collaboration goes on. In terms of kind of focusing more on the rivers, we have the Northeast and Atlantic, Mid-Atlantic River Forecast Centers, and you can kind of see their domains here. That's who we work with here locally, and their expertise is in the river modeling. They do the hydrologic modeling, looking at past precipitation, looking at soil moisture, snowpack. What are the current stream flows and stream levels, and putting this all together with the forecast. What's the forecast out for the next few days, next 3 days in terms of rainfall, or 5 days, and first coming up, what's the what is that, running it through their models, and then using their expertise, what does that mean in terms of significance, so major river flooding. But then also, there is all types of, there's numerous forecast points where the River Forecast Center along our larger stem rivers, where the River Forecast Center is going to provide forecasts. An example here, Walcalla Gardner, and again, running through their modeling, kind of QCing, using river stage data, reservoir release information, things like that, real-time information, and then using the kind of a collaborated deterministic rainfall for the next few days, and then running it through their models and doing, modifying using their expertise to come up with these river forecasts. But there's also probabilistic forecasts, and this is really where we're going in a lot of ways, is probabilistic forecast information, or an additional tool is using these ensembles of models to provide what are the, based on, what are the realistic possibilities in terms of rainfall and temperatures, say over the next 10 days, and then running it through these river models to give a range of possibilities in terms of water levels, and to kind of, so that with the most likely forecast is giving you a lot of information. What's the best case scenario, worst case scenario, most likely scenario in terms of these river point forecasts. And then I think what's exciting is coming up in the future here is taking that information, is the National Water Center, where they are going to take this to the next level, is not only doing that for main stem rivers like the River Forecast Center does, but then, kind of downscaling it or expanding this to all the small stream. And this is, I think, is really important for our area. We have a lot of flashy small stream basins that are not necessarily large stem rivers, but then that can rapidly flood due to heavy rains. And so being able to not just map right now, 3,600 river forecast points, have inundation mapping for 200 sites, but to be able to do this for over 2.7 million stream flow sites. That's what the National Water Center, which is really been ramping up, and to provide inundation mapping for all those areas. So I think, Emily, how much, am I out of time here, I think? Yeah.
You are, but
yeah.
It's such great information that, we didn't want to cut you short. So if you can take the next minute or two, if there's any final wrap up. We have some really great questions in the Q&A box, but in the interest of time, Nelson, maybe you can type the answers to those if you have answers to any of those, and but we'll give you a minute to wrap up here before we transition to the next speaker.
I appreciate it. Yeah, so it's basically taking, those are all our partners, taking all that information, and then us as the local forecast office, we're issuing the flood watches, warnings, advisories. Really the watches is the 12 to 48 hour, and really a 12 to 48 hour period to really provide that heads up that the potential is there for flooding, and really getting that information out to our partners. We have all our short fuse warnings, and probably the most important is the flash flood warnings and the river flood warnings. That means that there's a threat to life and property from the flooding that's approaching. And I think one of the things I wanted to key ones that I wanted to point out was the flash flood warnings is now, and we saw this with Ida, having the ability to have severity tags. We have base, we have considerable, catastrophic, and it's really these higher level flash flooding events where we're not only looking at the environment kind of heading into things, but then we're in analyzing the radar data, looking at observations, looking at emergency management reports, looking at some of the tools we have to look at rainfall rates, how that rainfall is turning into runoff. And really, when you see us putting out considerable tag and catastrophic tags, where you get VIA alerts on your phones, those are really the higher level flash flood warning, where it's an increasing threat to life. We're looking at more widespread and potentially catastrophic impacts. And this was with Ida, the highest level, that catastrophic flash flood warning. That's a flash flood emergency, where we're seeing everything in terms of the radar data, the environmental data, the observations, the emergency management reports, everything coming together. Basically, we need people to take their own lives and their own protection into their hands. And I think that was the key thing, is having these type of alerts. We wanted to kind of get that information. If you have any questions, we have, you can get our information on weather.gov. We're on Facebook, we're on social media. You can get it off our website. For all our partners, emergency management, media, academic partners, you can get on our email briefing list to get basically our PowerPoint, basically weather briefings, where we put all this information, a lot of information, put it all into something that's more concise, clear, and succinct to help you make actionable information that's hopefully meets your timelines. And with that, I'll kind of just finish up. If you have any questions, just some contacts. And I'll take a look at the questions in the Q&A there, but if you have any questions, please feel free to reach out to me or our senior service hydrologist who couldn't make it today, but Nancy Furbush, who's the our kind of water expert in our local area. So thank you for the time, and sorry for going over here.